Okay, in this video we're looking at 2021 paper 1 question 8. In A part I we're simply given a function h of x, and you'll notice the coefficient of x is unknown, it's simply a p. We're told that h of 10 is equal to 30, so we're asked to prove p is equal to 3.6. That means that if h of 10 equals 30, it means you should be able to sub in a 10 everywhere there's an x, and the whole thing will be equal to 30. So it's straightforward enough, you just sub in your 10, let it equal to 30, and if you solve it, you end up with p is equal to 3.6. Okay, so for part 2 here, we're asked to complete the table below, and hence draw the graph of h of x in the domain from 0 to 75. Now, I'm sure you've come across this before, and essentially, we're going to rely on our calculators for this. So, we want to essentially type in our h of x into our calculator using the domain from 0 to 75. So the first thing we want to do is we want to go to menu setup. So that's towards the right hand side of our calculator here, menu setup. And then now you can actually just select it straight away, but if I scroll to the right, that number 2 would give me statistics, number 3 would give me a table. So if you had just pressed 3 a moment ago, you'd get here anyway. I'm going to press 3 to indicate that I want a table. And now it's asking me to type in f of x, which in my case will be h of x. So I simply need to type in the cubic function that I've been given. I'm going to use 0.001, and then to get the x cubed, it's probably the only bit that tends to catch students out. To get x cubed, what you want to do is select this red x or pink x above the right hand bracket. In order to select the pink symbols, you press alpha up at the top here, and then our bracket. And notice that that gives me the pink symbol above the bracket, which is an x. And I'm trying to get x to be cubed, so I'm simply going to press x to the power of this button here, and 3. So you'll notice I've got my first term, 0.001x cubed, exactly the same as my h of x. Now the second term that we're looking for is minus 0.12x squared. So I simply select minus and 0.12, and now again I want to get x squared. In order to get the x, I press alpha and the bracket, that gives me my x, and then there's a button for squared, so I get it straight away. Now the next term we're looking for is px. We've already worked out that p is 3.6, so obviously it's 3.6x. So I simply press plus 3.6. Once again, to get my x, I press alpha, and then this bracket, and that's 3.6x. My final term is simply plus 5. So you'll notice here, and if I scroll over, you can see on my calculator, what I have here, the function f of x in my calculator is exactly the same as the function that we're trying to draw. Now we press equals. The calculator often asks us for a second curve, or a second function, because we can type in 2 at once. We're not really concerned with that, so we can just press equals. We can just press 0 and equals to indicate essentially I don't want it there. Now, we have to consider our domain here. Where do we want to start and where do we want to end? In this case, what I'm going to do is start at 0 and go the whole way to 70. The reason I'm doing that is because I can go up in tens. I already know what I'm going to get for 75, so I'm not going to bother plugging it into my calculator. So we're going to start at 0, end at 70, and our step is going to be tens because we want every 10th value. So that's what we're doing here. In order to start, we simply press 0. Once we've pressed our 0, you press equals to indicate to the calculator that's what you're looking for. Now I want to end at 70, so I press 70 and equals. So that tells my calculator the domain is from 0 to 70. But I don't want to go up in ones because I'll get 71 points and I have far too much information. I only need to go up in tens. So my step is going to be 10, and I press equals. And I can press equals again, and it gives me all of my values. Notice here I have 3 columns. The one on the left is the x values going up in 10, 0, 10, 20, 30, and so on. The second column, the one in the middle here, is the one that I want. These are the corresponding y coordinates for the function I typed in. Here it's indicated as f of x, but in my question it's h of x. So that tells me my first point is going to be 0, 5. You can see our second point is 10, 30. Our third point is 20, 37, 30, 32, and so on. You can scroll down and we can type in all of our values in here. Now, the other column here is the g of x, which we just typed in 0 for, and we don't care about it, so you can just ignore the column on the far right. Now that I have all of our points, we can simply plot our points on our graph, and we'll get ourselves a nice cubic curve. Okay, so once we've obtained those values, we simply plot them on our graph, and we come up with a curve. It's a cubic curve. Remember, it's a plus x cubed, so you should have been able to tell you were expecting to get a shape like this anyway. Now in B part 2, we're asked to show that there's a maximum point when x is equal to 20. So we have the original h of x, and remember, in order to get a turning point, we get the first derivative and let it equal to 0. We've already identified the first derivative, so all we need to do now is let it equal to 0. And this leaves us with an x squared, an x, and a number. This clearly just leaves us with a quadratic equation, and if we solve this, we'll find the x values of the turning points. That is a maximum point and a minimum point. So the easiest way to solve this is to use the minus b formula. My a is 0.003, b is minus 0.24, and c is 3.6. All I did on this line was I subbed in my a, b, and c, and I simplified it a little bit here. If you sub in the plus, you end up with x equals 60. If you sub in the minus, you end up with x equals 20. So we've verified that when x equals 20, a turning point exists. However, based on this, we can't tell whether it's the maximum turning point or the minimum turning point. If you look back at our diagram from part A, obviously it is the maximum came before the minimum. But in order to prove that the maximum point is when x equals 20, we need to get the second derivative. So let's just wipe off this. We've solved it there, but let's just consider how are we going to prove that when x equals 20, it's a maximum and that it's not a minimum. In order to do that, the first thing we'll do is we'll get our second derivative. The second derivative in this case would be 0.006x minus 0.24. So that's our second derivative. Now, we know that a turning point exists when x equals 60 and when x equals 20. But let's focus on the one for x equals 20 at the moment. If this is a maximum point, then that means we'll sub in x equals 20 into our second derivative and we'll end up with a negative value. If you end up with something negative, then that means it's a maximum. If you end up with something positive, that means it's a minimum. So in this case, x equals 60 is the minimum. If we sub that in here, we're going to end up with a positive number. However, that's not what we're concerned with. So now what I want to do is get my second derivative and sub in 20. In this case, it's going to be 0.006 times 20 minus 0.24. And fingers crossed, we plug this into our calculator, hopefully we'll get a negative value. So if you plug that into your calculator, the second derivative when x is equal to 20 is minus 0.12. So we can say, right, well, clearly the second derivative at 20 is less than 0. Because it's less than 0, we conclude that this is a maximum point. In B part 3, we're asked to find the height above ground at the point of inflection. Remember, to locate a point of inflection, you have to let the second derivative equal to 0. What we did previously to find the turning point, we let the first derivative equal to 0. But now we're going to use the second derivative. And it's incredibly easy. We already have the second derivative from B part 2. Now we just need to let it equal to 0. If I let this equal to 0, obviously I want to isolate this term, so I'll add 0.24 to both sides. And I'll get 0.006x equals 0.24. Then if we divide both sides by 0.006x, we'll end up with a value for x. 0.24 divided by this gives me 40. So I know that the point of inflection exists when x equals 40. However, this time we need to find the corresponding y value. We've been asked for the height above ground at the point of inflection. Or in other words, find the height above ground when x equals 40. To do that, we have to go back to the original function h of x. If I work out what h of 40 is, that'll tell me the corresponding y value at the point of inflection. And remember that we're told that the h of x represents the height. So once we get our y value here, that's our final answer. So straightforward enough there. All I did was I took my original function and sub in 40. When you plug that into your calculator, you end up with 21. So that means that the point of inflection is at 40, 21. We're concerned with the actual height, so we're concerned with the y value and we're asked to leave it in meters, so our answer is 21 meters. In the final part of question 8, we're asked to find the average height above the ground between 0 and 75. What should jump into your head here is your average value formula from integration. To work out the average height h of x from 0 to 75, you use this formula. It's 1 over b minus a, the integral from b to a of f of x dx. You should have that average value formula in your head. That's to work out the average value of a function over a given domain. The domain in this case is from 75 to 0. So my b is 75, my a is 0. Essentially, we need to multiply by 1 over 75 minus 0 and integrate the function h of x from 75 to 0. When I integrate the function, the x cubed becomes x to the power 4 over 4, x squared becomes x to the power 3 over 3, x becomes x squared over 2, and here if the 5 becomes a 5x. Notice the coefficients, they remain the same. The fraction here is obviously just 1 over 75, and my limits I have to sub in from 75 to 0. So what I did on this line was I subbed in my limits. The 1 over 75, I ignored it. I left it outside. Then here I've subbed in 75 into the first, second, third and fourth term. Then you sub in 0. But rather than writing it all out, I noticed if I sub in 0 into all of these, everything just becomes a 0. So when you sub in the lower limit here, it's irrelevant, it's just a 0. And 1 over 75 multiplied by all of this, my final answer is 20.47 meters. So the average height above the ground, or the average value of h of x between 0 and 75 was 20.47 meters.